Okay, so let's take a look at the second example set of problems. Here we're putting to use the product of powers, the quotient of powers, and the powers of powers properties. So we have these 9 examples. Let's begin. Number 1. Number 1 has 5 to the 2 times 5 to the 7. That is a product of 2 powers of the same base. So we keep the base as 5 and we add the exponents, 5 to the 9th. That's what you'll get. Sometimes what I see people do is they see that multiplication and they want to multiply 5 by 5 and say that it's 25. No, because remember, this 5 squared is 2 5s, and that 5 to the 7 is 7 5s, and you end up with 9 total 5s. It's not a 25 involved at all, so it's 9 5s being multiplied. There's your answer to number 1. Number 2, we see 8 to the 3rd over 8. This is a quotient of powers. They both have the same base. Maybe you're thinking that 8 doesn't have an exponent. Remember, every number or variable you see, if there's no exponent written, there is an implied exponent of 1. So this is 8 to the 3rd over 8 to the 1, which is 8 to the 3 minus 1, which is 8 squared. Now I'll accept 8 squared where this is to learn the properties of exponents. So this is showing you understand that. But really, you know 8 squared is 64. So I prefer to see 64, but oh my gosh, I'm happy to see 8 squared. Number 3, we have to simplify 7 to the 4th to the negative 5th. This is a power of a power. Whenever you see a power of a power, you're going to multiply exponents. So you're going to say that 7 to the 4 times negative 5, which is negative 20. And I wanted you to answer only with positive exponents, so you can't forget that negative exponent rule. Remember, that negative exponent is going to make that power of 7 show up in a denominator. So 1 over 7 to the 20th. That's your answer to number 3. Number 4, we have x to the 10th times x to the negative 14th. X to the 10th times x to the negative 14th. This is just like that first problem. We have the same base. We are going to add the exponents, so we'll have x to the negative 4th. When you add 10 to negative 14, you get negative 4. And again, that negative exponent, that's going to allow us to write 1 over x to the 4th. Number 5. Number 5 is a power of a power. We have y to the negative 3 raised to the 5. Power of power, we multiply exponents. So that's going to be y to the negative 15. And just like we did with that 7 to the negative 20, we wrote it as 1 over 7 to the 20. We're going to write this as 1 over y to the positive 15 when we reposition that negative power down to the denominator with a positive exponent. All right, so now for the rest of them. Number 6. Number 6, we have negative 3 in a quantity to the 10th over negative 3 to the 5th. Negative 3 to the 10th, negative 3 to the 5th, this is a quotient of powers. So what we're going to have to do, because we have the same base, which is negative 3, we're going to have to subtract the exponents. The exponent on the top minus the exponent on the bottom. So 10 minus 5 is going to be negative 3 to the 5th. And we're done. If you wanted to expand it, you could say this is negative 3 times negative 3 times negative 3 times negative 3 times negative 3, and you'll get negative 243. I'm content with you leaving it that way. But what I find people go crazy with is that negative exponent property, and they see a negative and they're like, I gotta move it, I gotta put it down in the denominator. No. That's not a negative exponent. If that 5 was negative, then we would be moving that power of negative 3. But this is done. This is our answer. Number 7. We have negative 2 to the negative 10 times negative 2 to the negative 3. Same base, product of powers. What do? Add, multiply. What do? We add, because that's in essence 10 of those, and this is 3 of them. When we multiply, we're going to end up with 13 of them. So this is negative 2 to the negative 13. Now this negative exponent, we don't want negative exponents, so we're going to have to reposition that power of negative 2 to be in the denominator. So we're going to have negative 2 to the positive 13 down in the denominator. That's number 7. Number 8, we have negative 5 to the 10th over negative 5 to the 13th. So we have a quotient, the same base. So what we can do is say we have negative 5 to the 10 minus 13. 10 minus 13 is negative 3. That negative exponent tells us we're going to have to reposition that to be in the denominator. So this is going to be 1 over negative 5 to the positive third. Now in reality, I just jump from this to the answer when I have a problem like this. Here's how I see it. I have 10 negative 5 factors over 13 negative 5 factors. Where do I have more negative 5 factors? In the denominator. How many more? 3 more. So I'm going to keep 3 factors of negative 5 in the denominator. So I see that 10 over 13, I'm going to have 3 extra in the bottom. So I keep those 3 extra in the bottom, and I just jump right to it. I bypass this step. I don't even write this step. So like what I'm saying is, if I saw x to the 10th over x to the 7th, where do I have more x's? Up top. How many more? I have 3 more up top. So I just end up with x to the 3rd. Likewise, if I see x to the 10th over x to the 20th, where do I have more x's? Down low. How many more? 10 more. So I keep those 10 more x's down in the denominator, and I just end it like that. That's what I'm talking about, how I bypass this step. I'm not going to this problem and saying I have x to the negative 10 and then go to that. I just look at where I have more x's and I keep them where they are. Oh, I'll get that later. Number 9. Number 9 is our last one. It's a power of a power. W to the negative 3 to the negative 6. Power of power, we multiply the exponents. So negative 3 times negative 6 is positive 18. So we have w to the positive 18, and that answer is done. All right, on to the next.